What this means is that I've paired the queue training with the storage container training big item. And now, anytime an item is put on the queue that exceeds Azor's queue limits, a pointer reference will be put on the queue, and the actual object will be put in the blob container. And as AzStudio's common APIs will keep those two resources in sync for the developer without any extra work. That is, in queuing something that's 10 megabyte is the same amount of work and the same line of code as in queuing something that's 40K. Queues, one of my favorite subjects. So, the first step in setting up your queue, basically the same as the blob. You're going to make sure that you have a storage account mapped into the AzStudio configuration database. We've already covered this, so it's all done for us. Next is to create a storage container type for the queue. This is the container that's going to service the queue. I'm pretty sure we've already got this set up, so let's check. No, we don't, so let's set one up. Let's call this queue training. And we're going to call it queue training -001. Again, the 001 is there to keep us from conflicting with other sandbox users. Okay, now that we've created our storage container, we create our routing, just like we did for blobs. We're going to do the same thing. We're going to set up routing for dev, QA, and production. And this will speed up my poor typing, so don't want to make you suffer through too much of that. And we're going to do the dev, and then we're going to use queues this time, and queue training. This will only take a minute. Okay, single instance, sandbox storage QA, and then we got queues because that's the API we're using, and that's the container we're using. And last but not least, production. And check it real quick. And there's our entrance. There's our entries into the system for QA training. At this point, our routing is all set up for all three environments for this particular queue. Now it's time to create a shortcut, just like we did in blob shortcuts. Let's go back there and look at this. See, just like we did for blob shortcuts, we're going to do queue shortcuts. And you'll notice we're starting to establish a pattern here, and this pattern flows throughout all of AzStudio, in that we're abstracting away, then creating this shortcut, and that's the only piece of information you have to communicate to your developers. So let's call this one training. Training, and let's call it queues and queues training. Great. So now I have a training shortcut for the queue training container. These don't have to follow any particular case or stylistic rules. I just happen to like them lowercase, but that's not required. You can type them in however you want. Okay, so let's actually test this. That's right, we're already ready to test our queues and make sure they're working before we even communicate the queue shortcut name to the development team. Isn't this nice? DevOps can set up resources, set up the actual config, test it, and then start development. The traditional way of programming is for DevOps to set up the resource, send the connection string to the programmer, the programming team decide what the shortcut name is, and then rely on QA or DevOps to test things once they deploy into the different environments, with a big Easter egg hunt happening if the config file for QA or production doesn't behave the way it did in dev. So let's select our shortcut, just like we would if we were a developer training, and then let's take a look at what our queue size is, which should be 0. Now you'll notice here the caching system is reporting to us that it has cached connection information to that queue. The blob API was doing the same thing, but we didn't pick that up in the log. And here we are. What that's doing is it's saying, okay, I went out to the queue, the configuration database. I found the connection for this particular environment and this particular resource, and now I'm going to cache that locally in memory on a per role instance so that I don't have to exercise the config database to reconnect or reference that resource again. Alright, so we know we've acquired and cached that information and that connection information for the environment. Had we not had that environment configured, it's going to tell us that we haven't configured it correctly and tell us what we need to do to fix it. Alright, so let's see what an error looks like and how you would immediately detect that you've done things wrong. Alright, let's select config. If you remember correctly, we didn't configure anything for the config environment, or we didn't put a routing entry in for this. So if we get queue size, you'll notice that AzStudio is going to flag us, and if we look at the log, it's going to tell us this environment ID, did not have a queue training for config. So yay, we can easily fix that, and we can easily detect it right away before the programmer gets involved or deployment happens to happen. Alright, so let's change our environment back to dev and proceed. Alright, so we're going to get our queue size and 0 again. So let's clear that. And let's write an object to the queue. And you'll notice here that the logging API is also trying to log into a different queue, and it, of course, records the fact that it referenced that and cached it, which is great. And now let's read an item from the queue. Alright, so time to point a few things out in our enqueue and dequeue methodologies, and point out some of the really great API enhancements we've done on these different access methodologies. Okay, first of all, you'll notice that we wrap the object that's enqueued in an additional wrapper, an AzStudio wrapper. This wrapper exposes a few things to the outside world in a consistent manner that aid you in your queue use and management. The first is we expose a type name. A type name allows you to read what type has been serialized into this entry without actually having to deserialize the physical class that you've enqueued. Why would you do this? Well, the first reason is that you might have a factory on the listener end, and you may only care about certain types that are in that queue, and you want to be able to quickly filter and parse them out. The second reason would be that you're using encryption in motion, and therefore you can't read what structure has been serialized into this message. So the best way to manage that is to put the type name or a type clue in the outer wrapper and then encrypt everything in the inner wrapper. In addition, we've got this technology called Big Item. Now, Big Item is something that AzStudio and our common APIs surface to the programming team. What they do is they help you deal with accessing resources or using resources beyond the limits set by Azure. This is accomplished by automatically mounting or mapping a storage container to the particular resource, in this case queues, but we do it for other API calls. Big Item allows you to mirror a resource and use it to exceed. With queues, this is really useful. If you wanted to enqueue a job, say, and that job included, say, an image or a video that you wanted to post-process up on the server, you would have to figure out a way to upload that image or movie file into a separate container and somehow keep them in sync while you enqueue the job, the post-processing job, to whatever worker you have on the background. But with AzStudio, it's pretty easy. To invoke Big Item technology, or to enable it for a particular resource, all you have to do is create a shortcut for that container in a blob mapping. Let's show you what we mean. So in our blob container, I've already set this up for you through the magic of pause, and I've said, okay, we have training blob, Big Item. Oh shoot, that's not going to work. Never mind. Dope. So, how do we enable Big Item for a resource? Okay, well, the first thing you do is remember your resource, which is training, and now go over to your blob shortcuts and create a new shortcut called whatever that resource name is, _Big Item. That's all you have to do. You do have to set the routing for that particular blob container. But once you've done that and you've got the shortcut name with the underscore big item, the AzStudio APIs will pick up on that and know that you want to pair that container with that particular resource. What this means is that I've paired the queue training with the storage container training big item. And now, anytime an item is put on the queue that exceeds Azur's queue limits, a pointer reference will be put on the queue, and the actual object will be put in the blob container. And as AzStudio's common APIs will keep those two resources in sync for the developer without any extra work. That is, in queuing something that's 10 megabyte is the same amount of work and the same line of code as in queuing something that's 40K. So let's watch big item in action. Let's write a big item to the queue, and then let's read it from the queue. And as you can see, we've exercised this queue with a 1 meg data object. And you'll have to take my word for it. There's a million pieces of data in that particular queue item. Okay, so let's now demonstrate testing the queues in the different environments and making sure they're actually set up and receiving and sending data correctly. So the very first thing we're going to do is we're going to write to the queue, and then we're going to get our queue size, which happens to be 2 at this point. Now let's change our environment to QA and go back to our testing tool and then check our queue size there. You'll notice that because we haven't referenced this queue going forward or in the past, we'd have to cache that particular reference. Now let's read that queue, and nothing's there, which is to be expected. We've exercised. We're in QA now. Now let's go back to dev, go back to our tool here, and now read from queue. Oh, there's a big item. Let's read another one. And there's a regular item. So as you can see, I was able to flip between my environments and test my physical resources in Azure and make sure that everything's configured to work properly. Now's a good time to discuss some of the extra features that we've embedded into this API. We've embedded them into other APIs, but this queue tester really demonstrates it to the fullest. First thing we can do is toggle an encryption engine that directly encrypts and decrypts the queue contents as it's being streamed out and in from the Azure PaaS resource. It also has the ability to map your own encryption engine into that stream so that you can control how data is encrypted and decrypted and by whom in real time. In addition, we put a poly retry library around all of our APIs. So if I go here into transient fault handling, give it a second, it's going to come up, and you can see that you're capable of setting up any kind of transient fault handling to any Azure resource based on both the API being consumed and the environment that it's running in. This gives you the ability to make transient fault handling extremely strict in, say, the dev or QA environment so that you can test and respond to fail states. But when it's in production, you can give a much more loose transient fault handling policy so that the resource won't fail quickly, it'll fail slowly, which is what you want in a PaaS environment. Now let's tie this all together. Let's show you what the coder has to do on their end. This coding card is something that we include in many of our API managers, and you'll start to see more of them as we mature the product. So let's take a look under the hood for queues. And by the way, blobs and table storage are going to work pretty much the same. Matter of fact, accessing almost any resource in Azure gets boiled down to this kind of API sequencing rather than the more complicated APIs that Microsoft exposes in their packages. So now you can see in the first line of code, getting the queue reference, our APIs all start with the word, the letters AZ. You'd see this a lot in jQuery where you have $. Well, we have AZ dot. In this case, it's a queue manager because we're working with queues. And you'll notice that we want to get a queue reference. This is where that shortcut name is provided to the programmer. This is really the only piece of information the programmer has to be aware of. Then we have peeking a queue, place an object in the queue. I think that's pretty easy. DQ, how many we'd like to DQ. How we would like to process the deletion of marked items in the queue. And then here's an example of iterating the queue, processing the items in the queue, and marking them for delete, plus a set of tips for the programmer. So it's pretty easy to get a coder started working on this resource. And it all comes together now, right? You've got the provider. It's connecting to the configuration manager. The configuration manager is reading the data that you are putting in through AzStudio. You've tested this data to make sure it works in all environments. And the programmer is consuming that configuration data through a very simplified shortcut name. This is going to really increase the reliability and repeatability of working with these resources. So that's it for queue basics. Next thing we're going to move on to is table storage. So thanks for watching.